Alright, so here are the answers to the flipped problems for chapter 6 and chapter 7 in your unit 3. So the first classwork problem is the energy of an energy of 2.0 times 10 raised to 2 kilojoules per mole is required to cause a cesium atom of a metal surface to lose an electron. Calculate the longest possible wavelength of the light that can ionize a cesium atom. In the region of electromagnetic spectrum is the radiation found. So first thing is, this is given kilojoules per mole, so you need to convert the kilojoules per mole to kilojoules per photon and then to joules per photon, because when we are using the formula of energy equals h times frequency, this is an energy of a photon, not for per mole. So kilojoules per mole, 1 mole has 6.02 times 10 raised to 23 photons. So now you have kilojoules per photons. You need to convert the kilojoules to joules because this energy is also in joules. Why? Because the Planck's constant is joules per second, joules times second. Okay, so we have to make sure that we have everything in correct units, and as a result we do this step to convert it into joules. Now we just use the formula. These values are given to you behind the periodic table, so you do not have to memorize it. You solve for the frequency, you plug in the numbers, and you will get the answer. Okay, now convert to wavelength. You would convert the wavelength. We know wavelength is speed of light divided by frequency. Once again, speed of light is given to you at the back of the periodic table. It is good to know this constants. You use the value of the frequency that you calculated in step 2, and you will have the answer. Make sure you're putting it in correct Ch.6. This region, if they have specified, it is good to know that 400 to 700 nanometers is a visible range. So I would recommend just remembering that. Now the first problem in our chapter 7, which is based on periodic trends and electron configurations. So using an orbital diagram and noble gas notation, depict the electron configuration of vanadium and vanadium ions, and are they paramagnetic? So first thing is, we will write down the electron configuration of each of them. I hope we all feel comfortable doing that by now. When you are removing the electrons, you always remove from the highest energy level. So here 4 is your highest energy level. As a result, you're going to remove 2 electrons from here, and so we get this electron configuration. Now when we are talking about this, we have removed 2 electrons from here, and then we are going to remove the other 3 electrons from 3d3, and as a result we get this electron configuration. Now we are going to write down our orbital diagram. We know when we have the electrons 4s2, they are going to be paired. We have 3 electrons, they have 1, 2, 3, 4, 5 orbitals. They all have to be unpaired. Now when we are talking about vanadium ion with a 2+ charge, we have removed those 2 electrons, and these both are going to be paramagnetic because of the unpaired electrons that they have. While if we look at V5+, it is going to be diamagnetic because all these electrons are going to be paired. All the electrons in its valence shell have been removed. That is between 4s and the 3d, so that is going to be diamagnetic. The next problem that you have is, arrange the following elements in order of increasing size. They all are elements. Try doing this without looking at the figure, and then look up by yourself. So that means without looking at the atomic radius. One thing that I would recommend is looking at the periodic table and identifying the number of protons and the electrons. And we should know that the atomic radius decreases as we move across the period, and it increases as we go down the family. It decreases because of the nuclear effective charge increasing as electrons are being added to the same energy level. So now if you look over here, we see that potassium is in the 4th energy level. As a result, we should know that is going to have the largest size. Now when we are looking at aluminum and sodium, they both are in the 3rd energy level. But if you look at sodium and aluminum, as we move across, atomic radius decreases. The other thing is, aluminum has a higher nuclear effective charge, and as a result it's going to have a smaller radius compared to sodium. And then if we look at boron and carbon, again they both are in the same energy level, but carbon has more electrons, so more nuclear effective charge, and as a result it is going to be the smallest, and also atomic radius decreases as you move across the period. And the last question in your homework problem set in chapter 7 is select an atom or an ion in each pair that has a larger radius. So it is always a good idea to write down the electron configuration, right? So if you're looking at chlorine, chlorine is 3s to 3p5, and chlorine ion is going to be also in the third energy level. But now what is happening with chlorine? Chlorine and a chlorine ion, they both will have 17 protons, but now you're going to have more electrons in a chlorine ion, and as a result of more electrons there is going to be a electron repulsion. So the same number of proton results in the same nuclear effective charge, but gaining an electron increases the electron repulsion in a chlorine ion, and as a result chlorine ion is going to be larger. Now if you're comparing aluminum and oxygen, aluminum has more valence electrons and it is in a higher energy level, and therefore aluminum is going to be larger than oxygen, since aluminum is in the third energy level and oxygen is in the second energy level. And now if you're looking at indium and iodine, they both are in the same energy level, 5, and therefore iodine has a higher nuclear effective charge because it has more protons compared to iodine, and because more nuclear effective charge, that means it's going to be smaller, and as a result indium is going to be larger. Now what is important, since they're asking you which one has a larger radius, make sure in your answer you are saying which one is larger and not talking about which one is smaller. I hope this helps. If you have any questions, please ask me in class.